Hey everybody, it's Mr. N here, and we are going to do the 7-6 lesson. And this is on inverse trig functions. Now you got a handout that has all these formulas. So basically what you'll need to be doing is this is what you will need to memorize. All this. All right, let's go back and take a look here. First of all, let's start with this. Starting with what an inverse trig function is. If we take a look at the inverse sine, remember what you had learned in prior classes. You were taught that if you had the sine, let's get the right pen in here, the sine of an angle is a ratio, just like the cosine and the tangent would be. And to solve for the angle, you can't just simply divide by sine, because it'd be like sine of what? So can't do it that way. So what we use is an inverse function. So we have the inverse sine of whatever this ratio came out to be, and that's what your angle is. Now remember, in calculus, we're always going to keep our angles in radians. But if you were to graph the inverse sine, you will see that it's can only be graphed on the interval from negative pi over 2 to pi over 2. The other thing you need to be aware of, and they will state this on the top of every AP test, is we have this word called arc. The arc sine just means this inverse. So sometimes you'll see it as the arc sine, and that just means the inverse sine. So it's the same word, just a little bit different. So just be careful with that. When you see it on my tests and quizzes, I'll use both. I'll use the inverse sine and I'll use the arc sine. That way you understand them both. So if you take the inverse sine of the sine, you should get x. If you take the sine of the inverse, you'll get x again. But be careful. For this one, here is the domain. For this one, here's the domain. So just be aware of that. Same thing happens for cosine. Same thing happens for tangent. And these are the domains for the, I should say ranges when you do the arc sine, for the cosine and the tangent. So we're get down to here. These are all the things I had just said you need to memorize. If you are taking the derivative of the inverse, so the derivative of the arc sine, that's 1 over the square root of 1 minus x squared. Remember, you have to do the chain rule always. So this is where, if this x was some sort of function, this is where the chain rule would take into effect, times the derivative of that function. Same thing with inverse cosine, same thing with inverse tangent. You have to always do the chain rule. So these are the same things with the chain rule, but the basics of the inverse cosine is negative, so these differ, and that's 1 over 1 minus x squared. The inverse tangent is 1 over 1 plus x squared. Here it is with the chain rule, like we said. And let's move this up a little bit. You have the inverse of the cosecant, and the inverse of the cosecant would be negative 1 over x times root x squared minus 1. And here it is with the chain rule involved. So you would take the derivative of that function. The inverse of the secant is 1 over x times root x squared minus 1. Notice all of these pretty much are very similar. I mean, it's just you might have a negative. Here's the inverse tangent. Here's the inverse cotangent. Notice this doesn't have the negative. That does. So memorization-wise, I would probably just use note cards. Put them on note cards. Try to memorize them. Be careful with those negatives. And now we get to the integrals. The integrals are a bit harder because you're going to probably need to use a substitution rule when you solve these. You could try to do it with guess and check, but sometimes it's a little bit harder that way. But here's the integral of 1 over root 1 minus x squared. Notice that it's going to follow the pattern up here. And this would be the inverse sine. See that? And here it is as the integral of 1 over x squared plus 1. That's the inverse tangent. And the integral of 1 over x times root x squared minus 1. Now be careful. For these values where this isn't 1, notice how this is a. This isn't 1, that's a. That isn't 1, that's an a. If it's something other than 1, you have this situation occurring. So let's take a look at the inverse sign. You have 1 minus x squared, that's root on the bottom. But if this was something else, suppose a squared was 9, that means a would be 3, you would have to put this part right in here. That's how it differs. And I'll show you some examples with that. But notice these two have 1 over a, this one does not. There is a reason for that. When I see you guys next, I can explain it to you. What ends up happening though is if you were to put that here, it does reduce out. So that's just the basics of it, but you don't need to know that for the AP test, but I'm just showing you why this one doesn't have 1 over a, because if you were to have put it there, it would have canceled out. All right, let's move on and see what we got next. We're going to do some examples. All right, so let's take a look at these examples. I know this lesson's a little boring. Try to spice it up, but can't. My wife's sitting across from me, and she doesn't find me funny. I guess neither do you guys, but that's okay. All right, over here. Take the derivative. First one is the inverse sine of x. So we will use our formulas from the other page, and we could do this. I'll go ahead and do it with a substitution rule so you could see the whole thing. So we'll say if u equals x squared, then we know that du equals 2x dx. So that now we can say f prime of x will be 1 over the square root of 1 minus u squared du dx. This was the chain rule version of it. And then we can substitute this in. 1 over the square root of 1 minus x squared times du dx would just be the 2x. So this is your final answer. Now, if you just remembered what the chain rule would be, you could just go ahead and base it off that definition that we know and just say that this is going to be 1 over the square root of 1 minus, here's my a, right, because it's a squared. So this is x squared times, now I have to take the derivative of this, which is 2x. Same answer. All right, moving on to the second one. And on the second one, this time we have the inverse cosine. So we know that the formula for the inverse cosine is negative 1 over 1 minus that x squared times whatever the chain rule part would be. Here is that part where it's this squared. So let's work this out. We have f prime of x will be negative 1 over root 1 minus e to the 2x. This would be squared times, I need to chain rule this part. So the chain rule on this would be e to the 2x times 2. Because I need to take the derivative of e to the 2x. Derivative of e to the 2x is e to the 2x times 2. That's what we have there. So we can try to clean this up a little bit. Not much. Nothing's really going to clean up in this. This would be negative 2e to the 2x all over the square root. You could rewrite this as 1 minus e to the 4x. All right, moving on to number 3. All right, number 3. So we know that if we take a look at the tangent, the inverse tangent formula from above that we learned is going to be 1 over 1 plus x squared times the chain rule part, right? And look at what we got here. This is a little crazy. We have this 1 over x plus 1. This is that u part. That's the part that's going to go in there. So the derivative of this will be 1 over 1 plus this thing, 1 over x plus 1. Now guess what I got to do? I got to do chain rule on that. Well, let's just kind of do it on the side over here. The chain rule on that, remember, I will have x plus 1 to the negative 1. So taking this derivative, this gives me negative 1 times x plus 1 to the negative 2 times 1. So really what I just have here is times negative 1 over x plus 1 squared. So cleaning all this up, f prime of x will be negative, or let's write it all in, 1 over, you know what, I forgot to put the squared there, I just realized that, 1 over 1 plus 1 over x plus 1, this squared, times the negative 1 over x plus 1 squared. Now, you could leave this like this, you could distribute it, and if you did distribute it and kind of cleaned it up a little bit, you'll get f prime of x equals negative 1 over x plus 1 squared plus 1. My wife just sneezed. And then if you even take it a step further, you'll get negative 1 over x squared plus 2x plus 2. Yes, we're both working from home today. So either way, know how to, if it's a free response, obviously you leave it like this. If it's something that comes up on multiple choice, well, you're going to need to know how to reduce it down all the way, because they may present the answer this way or they may present the answer that way. So just be aware of that. All right, so let's do number 4. I'm going to need quite a bit of room for number 4, so I might write here a little bit smaller. Let's just see how this works out. Okay, so for this one, we have x times the inverse sine, or inverse secant of 1 over x. So we're going to need to do a product rule here, because I've got this times this one. So f prime of x will be the first times the derivative of the second. Now, the inverse secant, when we look at our formula above, is 1 over x times root x squared minus 1 times the chain rule part. So that would be 1 over x times root, remember this is like my u, and we had said it's going to be, let me write it down for you again, it's 1 over this u times the square root of u squared minus 1 times the du. Okay? So, we end up continuing on, so we have the 1 over x, now we have root 1 over x, this thing squared, minus the 1, times, I have to take the derivative of this 1 over x, and that's going to be negative x to the negative 2. So first times the derivative of second, plus the second, inverse secant 1 over x, times the derivative of the first, which is 1. All right, let's see what we got. Let's slide this up a little bit. And trying to clean this up now. So we did the derivative, now let's see if we can clean it up. So f prime of x will be this x, and what I'm going to do is I'm just going to rewrite this part over here. So this is going to be 1 over this 1 over x root, and I'll go ahead and put this as 1 over x squared minus 1 times the negative 1 over this x squared plus this inverse secant of 1 over x. All right, at this point, I can find a common denominator for this right in here. So right in here is what I'm going to try to focus on, find a common denominator. That's going to be x squared. So let's rewrite that. This will be f prime of x equals x times, this is 1 over x root, and this will be 1 minus x squared over x squared times negative 1 over x squared. The reason why I found a common denominator plus this inverse secant of 1 over x, because it'll let me distribute a couple things and clean some things out. So here you have this 1 over x, you have a multiplication. I can reduce this with one of those. I could take a root x from the bottom over here, take that out, do a couple other steps to clean it up. And just because, whoa, what just happened? Just because I'm running out of room here, I'm just going to show you a couple of those steps. And then you end up with just a couple of those things. And then here's what you end up with, actually, when we're done, when we get towards the end. X, and then you get x squared over root 1 minus x squared times this 1 over negative 1 over the x squared plus this inverse secant of 1 over x. When all is said and done, you end up with f prime of x equaling negative x over root 1 minus x squared plus the inverse secant of 1 over x. Yes, I did skip a few steps from here to here. It's just simplification steps. Go ahead and try it out on your own, but that's what you should end up with when all is said and done. All right, moving on, let's do some more derivatives here. Emily, say hi to everybody. Emily, say hi to everybody. Okay, she's running off. All right, so let's take a look at this next one. This is the cosine of the inverse sine of negative 1/2. All right, well, first we're going to work this one inside out. So going inside out, let's take a look, and that would mean let's find what this is. The inverse cosine of negative 1/2 is negative pi over 6. All right, so we take a look at our unit circle, which we should have memorized by now, right? You all know your unit circle so well. At pi over 6, I have the coordinate here. This is root 3 over 2, comma 1/2. At negative pi over 6, I would have the root 3 over 2, comma negative 1/2. So that's where this one comes into play. Matthew, say hi to everybody. Hi. All right, so we know what this answer is, so now I end up with the cosine of negative pi over 6, and I have to solve this. And if you take a look at this, the cosine at negative pi over 6 is root 3 over 2. So what does this problem tell us? It tells us that you need to memorize your unit circle again. So be aware of that. Memorize that unit circle. I will put links for you so you could print out another copy so it can help you memorize it. Okay, moving on to number 6. It's very similar in that it involves knowing our unit circle. So let's take a look here. Let's choose purple. Okay, 4. The cosine of 2 pi over 3. You take a look at your unit circle. 2 pi over 3 is right around there. And this coordinate is 1/2, comma, root 3 over 2. So we know it's actually negative 1/2. Sorry, that's a negative 1/2. So the cosine of 2 pi over 3 is negative 1/2. So now we have the inverse sine of negative 1/2. And we already know that from over here from the first problem. So this will give us negative pi over 6. And finally, on this last one. All right, well, negative 3 is not on my unit circle. So now you have to do, remember those things you learned about reference angles where you kind of have to make a little chart here and you have negative 3. So we know that the inverse tangent of negative 3 is what my angle is. So we could really write this as negative 3 over 1, right? So that means I have to make a reference angle with this as being 1, this as being negative 3. There's my theta in there. So there's where my tangent of theta, okay, would be this ratio of negative 3 over 1. So the inverse tangent of negative 3 would be the theta. And now I can use that to solve the rest of the problem. And in this case, since I need the secant, this would give me root 10 right there. And I would need the secant at this point of that theta. And the secant is 1 over the cosine, and the cosine of this would be 1 over root 10. So the secant of this theta, when all is said and done, is the square root of 10. All right, number 8. Let's move this up. A particle moves along the x-axis so that its position at any time t greater than or equal to 0 is s of t equals the inverse tangent, root t. What is the velocity of the particle when t equals 16? So for this question, we need to determine what the position, well, we know the position, we need to determine the velocity. So we know that the velocity is the derivative of the position, and my position is s of t equals the inverse tangent of root t. So I need to take s prime of t, and that will give me 1 over 1 plus root t squared. Now I have to take the derivative of this guy, and that will be 1/2 t to the negative 1/2. So again, I used the formula for the tangent, which was 1 over 1 plus this x squared, this was my x in here, times that chain rule. Okay, times the derivative of that. So cleaning this up a little bit, let's just see where we end up. We will have 1 over 1 plus t, this root squared, times 1 over 2 root t. This equals 1 over 2 root t times the 1 plus t, and they want to know when t is 16. Obviously, you could have just plugged it in right here, right? We could have done that, but I just wanted to simplify a little bit so you can kind of see the process in case you had to simplify for some reason. This ends up being 1 over 2 root 16 times 1 plus 16, and you get a final answer of 1 over 136. And this doesn't give us the units, so we'll just say velocity, so we'll just say units per second. Moving on to number 9. For number 9, we have to find the derivative of the inverse secant. Now, again, I'm going to look at my formulas sheet up there, what the derivatives are, and I will see that this is the u. And for the secant, we have 1 over u times this u squared minus 1 times this du dx, right? So basically, this is what I'm going to put in here and here, and I'm going to take the derivative of that for the chain rule. So we end up with 1 over 5x to the 4th times root 5x to the 4th squared minus 1. Now the chain rule part, I have to take the derivative of this, which is 20x to the 3rd. Cleaning all this up, this will go with that, make that a 4, 3 of these with 1 of those. So you end up with 4 over x times the square root. We'll go ahead and work this one out. 25x to the 8th minus 1. And there we go with that one. All right, let's move on and see what else we got. We have even more examples, and now we're going to get into some of the integrals. These are a little bit more difficult, so pay attention to how these are done, and hopefully we can get these practiced. So for number 10, we've got the integral of dx over root 4 minus 9x squared. We need to write this in a form that we can recognize. So suppose I let you, I'm going to go ahead and do it showing all the steps right now. And we let u equal the 3x. Because usually when you look at those formulas, it's always this something that's squared here is going to be your u. And this was your 1 in some of the cases, but in our case it's going to be the a squared. So to me this looks like a squared minus u squared. So that would mean my a in this case would be the 2, right? Because a squared would be 4. So if you let u equal 3x, then you know that du will be 3 dx. So we could do the full substitution rule on this and say the integral of dx over the square root of 2 squared minus this 3x squared times, and if I go ahead and substitute this du, I'll get, and I do make this as a du, I'm going to substitute it, I'll get the du over 3. So let me see if I can erase this. Sometimes it doesn't let me erase so well. There it goes, it did it. Okay, so let's go ahead and substitute this in as, we'll say 1, oops, we'll say 1 right here, and then we'll say du over 3. All right? So this was my u, so let's go ahead and put that in, and let's make the full substitution. This would be your, remember it was our a squared, so we'll say put the 1/3 out in front. This is the 1/3, right? This will be 2 squared minus my u squared. And this will be my a value, and I'll have a du. So looking at all of this, I have this as being the inverse sine. And where did I find this? I went straight back up here. I went way up over here, and I looked at my formulas, and here is a situation where I had my a squared minus the u squared, right? This would have been our u, a squared minus u squared. And I think I put this in on your handout possibly as u's. I just didn't change the one on here. Okay? So let's go back and continue on. Okay? So this would be the inverse sine of u over a plus c. Well, what is our u over a? Our u, we said, was 3x. A, we know it as being 2, so that's what's going to go there. And don't forget, I have this guy following along. This one isn't part of my formula. This one is just going on for the ride because it was a constant that was out in front. So we end up with 1/3 the inverse sine of 3x over 2 plus c. All right, let's do a second one, and hopefully things will start clicking after this. And I'm going to give you a few more, in fact, after these two last examples. So for the next one, let's identify what the u and what the a ones are. So this is what our u is. This is our x that we're talking about. So we can say let u, let me go ahead and change the pen color here so we don't get it confused. We'll say let u equal this e, and I'm just going to call it to the x. I'm not going to call it to the 2x. Here's why. When our formulas, we have x squared. Notice here I let u equal 3x, because when I square it, I'll get the 9x squared. Here, I'm just going to say e to the x, because when I square it, I will get e to the 2x. And why am I doing that? Because in the formulas, looking again, we're trying to identify what this is, not the squared, because we know we're going to have to square it. What the a is, not the x squared. What the x, or the u in this case, is, not the u squared. So the squared is part of the formula, so I want to identify what it would be before I square it. All right, coming back over here. So I identified what my u is, and let's go ahead and identify what the a is, and in this case, the a is just simply 1. All right, so I'm looking for the one where I have x squared minus a squared, and that would be the inverse secant. So, since I identified my u, let's find out what du is. That would be e to the x dx. So I could say that du over e to the x is my dx. And we know that e to the x is u, so I could say du over u is my dx, right? Because look up here. We knew that e to the x was the u, so I could just put the u back in right there. And now I have gotten rid of any of those e to the x's. All right, continuing on. So let's go ahead and put this inside, and we'll say the integral. Now this is du over u, right? I substituted my dx. And this will be the square root of u squared minus 1. And I know that this is the inverse secant. We're going to say 1 over a, the inverse secant of u over a plus c. So this is 1 over 1, the inverse secant of e to the x plus c. So it's just the inverse secant of e to the x. E to the x plus c. Okay. Moving on to the next one. The next one, you could try to do some weird things and try to factor out the bottom, but it won't factor. But I was just trying to trick you here. And if you kind of take a look at it, you'll see something that stands out a little bit. Notice it's bounded. Right here, it's bounded. Right? And you can't factor to do anything. I'm just going to tell you use your calculator on this one. So, right, we're going to use the FNINT feature. Plug it in. You use your calculator. I'll give you a second to do that. Or you could pause the video. And then when all is said and done, you should get 1.27438. So sometimes you'll get something mixed in like this that just you're not going to be using anything funky like the inverse trig functions. All right. That's it for your notes, but I want to add 3 more problems to make sure that you know how to do this. So let's put some space right here. And after each problem, I want you to pause the video and go ahead and try to do it and see if you can come up with the same answer I do. So these are going to be extra problems. So for the first one, let's say we've got the integral of dx over, we'll say 9 minus 16x squared. All right, go ahead and pause the video at this point and see if you can do the problem. All right, so what'd you get? Hopefully you got this answer. Let's write it in. Let's see if you got it as well. The final answer should have been 1 over 4, the inverse sine of 4x over 3 plus c. Yes, I know your hands are up. How did I get that? Okay, let's do this. So, over here, we are going to identify what the a and what the u are. And in this one, this is a, which would be 3, and this would be u, which would be 4x, right? It's what when we square it, we get this answer right here. So we want to see what it was before we squared it. So if I let u equal 4x, du would be 4 dx. And over here, I know my a value, so I could rewrite this whole integral to say dx over the square root of 3 squared minus the u squared. And I identify this by looking up above and at my and the handout that I gave you that has everything on it. I identify this as being the inverse sine. So this is right here, du over 4. So when I substitute this in, I'll end up with du over 4. I forgot to substitute the dx in. And then this will be 3 squared minus the u squared, right? And we said u was 4x, correct? So this is my u, and that will come outside as 1/4 times this integral. So I have 1/4 as my constant. This has nothing to do with the formula. This is just the constant that comes outside. And this will be inverse sine, and I'll have right here u over a plus c. So we end up with 1/4 inverse sine of u, which is the 4x, and the a, which is 3, 4x over 3 plus c. All right, let's put a second one up here and have you guys do another one. So let's do number 2, and number 2 is going to be the integral of dx over 25 plus 9x squared. Okay, pause the video. Let's see if you can do it. All right, so hopefully you are able to do this, and the answer to this comes out to be 1 over 15, the inverse tangent of 3x over 5 plus c. All right, how do we do this? Well, we said a is going to be 5. We let u equal 3x. So a was 5, u was the 3x, so that meant du, 1/3, we'll say du equals 3 dx. So 1/3 du is your dx. So you make your substitution. You have the integral of 1 over 5 squared plus the u squared, and this will be 1/3 du. This right here is, we need to take a look and see what this is. Again, you're using your formula sheets. You're trying to figure out which one it is. And when you have this situation, it's going to be the tangent. Let's go ahead and identify it. Here it is. You have something squared plus the a squared. These could be flip-flopped. It's okay. And you get 1 over the a. And in this case, the a is 1/5. And then we have x over a, which is, in our case, the u over the a. Okay, so let's put all of this in and see where what we have. Okay, back to here. So right here we said that this ends up being 1 over the a, and I have this constant out in front. The 1/3 came out in front as my constant. My a, we said, was 5. So I have 1 over a, which is 1 over 5, times the inverse tangent of the u over a, and my u was 3x, my a was 5, plus the c. You can clean all this up and say 1/15 times the inverse tangent of 3x over 5 plus your c. All right, let's put up one more and see if you can do it. And I kind of am running out of room here, so we'll put it right in here. And this is number 3. We'll say the integral of 1 over x times root 4x squared minus 81 dx. Pause the video. Let's see if you can do it. All right, so you should have gotten, let's see, let's find another color here. Let's go back to red. You should have gotten 1/9 inverse secant 2x over 9 plus c. All right, let's explain how. This this is my u, which is 2x. This is my a, which is 9. And you recognize and you look at the formula sheet, which of these gave me 1 over the x times u squared minus a squared, or x squared minus a squared. That's what you're looking for. And again, these are all things you have to memorize. That's the hard part about this lesson, is that all of that, you don't get to use that on the AP test. None of those. You have to memorize them. So again, put them on note cards. All right, so working this out, we're going to get, if we let u equal the 2x, du will be 2 dx. So du over 2 is your dx. So that means we're going to have a constant there. So I can rewrite this whole thing right now to be 1 over, and x we said was, if I solve this for x, u over 2 is your x. U over 2 root u squared minus the a squared, right, times your du, whatever that comes out to be, which we already have. So let me make all the substitutions now. U over 2 root, this will be u squared minus 9 squared times 1/2 du. So this was a dx right now, and I made it into the du. So we end up with the integral of 2. I'm going to move that to the top there. And then I'll have a u. This will be u squared minus 9 squared times the 1/2 du. These will reduce. You end up with the integral of du over, and here's where you look to recognize it, u squared minus 9 squared, which is your a, right? A squared. And this is our inverse secant formula. So we end up with 1/9 the inverse secant of u over a plus c, which is 1/9 the inverse secant of 2x over 9 plus c. And there you go. Hopefully you're able to do these examples. Go back, rewind, walk through them again. These are not too easy. Again, one of the hardest things though is that you have to know all of this right in here. So you have to memorize all of this in here. Okay, you have this handout. I will also post a link to it again if you need to print it out again and put these on note cards and go ahead and memorize them. All right, guys, thanks for watching. I know learning from home is tough, so feel free to put comments down below. Hit that subscribe button. I know you guys always want me to say that. Smash that like button. But anyway, put comments down below so that if you have a question on something, maybe somebody, or I'll try to see if I can monitor the comments as well, answer it for you. All right, good luck.